Hey guys, welcome back. Today we are going to do transformations on shapes in a coordinate plane. So first we're going to do dilations, and we're going to do these using matrices. So for dilations, that means we are either going to expand or shrink a shape. Okay, so a dilation is when something grows larger or it's smaller. So a triangle with vertices 2, 3, 4, -2, and -4, 0, we are going to dilate with a scale factor of 2. So in order to do that, we're going to put the coordinates into a matrix. And I'm sorry about that little break right there. For some reason, this program breaks up some of those brackets, so we just have to pretend it's not doing that. So the x-coordinates go on top, so that's 2, 4, and -4 across the top. And the corresponding y-coordinates, 3, -2, and 0 across the bottom. So that builds us a matrix for the coordinates of triangle ABC. And we're going to dilate with a scale factor of 2, so we are going to do scalar multiplication. So that gives us all of these multiplied by 2, 4, 8, -8, and 6, -4, 0. So the coordinates become 4, 6, 8, -4, and -8, 0. So there's our triangle dilated by a scale factor of 2. So next we're going to dilate a quadrilateral with these vertices by a scale factor of 0.5. So that's 0.5 times, and then we've got -2, -7, 6, -2, 0, 3, -6, -4. So that is -1, 3, 0, -3. Those are our x-coordinates. And our y-coordinates, -3.5, -1, 1.5, and -2. Okay, so we'll do our best to approximate those decimals. We've got -1, -3.5. About right there. And then 3, -1, 0, 1.5, and -3, -2. So we notice this one actually got smaller, but we're multiplying by a decimal between 0 and 1, so that is going to shrink the shape. So next we're going to do translations with matrices. The translation is a shift. Sometimes people call it a slide. Okay, so we're going to translate a triangle with these 3 vertices, same as the first problem. 3 units right and 5 units up, and to do that we are going to use addition. So we are adding 3, -5 to all of these coordinates. Okay, so we add all of our corresponding elements. 2 plus 3, 4 plus 3, -4 plus 3. And then 3 plus -5, -2 plus -5, and 0 plus -5. So our new coordinates are 5, -2, 7, -7, and -1, -5. Okay, so now we are going to translate our quadrilateral. So it's -2, -7, 6, negative 2, 0, 3, negative 6, negative 4. 2 units left, so left would be negative 2 to all of the x coordinates, and 4 units up, so that's a positive 4 to all of the y coordinates. Negative 2 plus negative 2, 6 plus negative 2, 0 plus negative 2, and negative 6 plus negative 2. And then adding 4 to all of the y coordinates. Negative 7 plus 4, negative 2 plus 4, 3 plus 4, and negative 4 plus 4. So we have negative 4, negative 3, 4, 2, negative 2, 7, and negative 8, 0. Okay, reflections and rotations with matrices. When we do a reflection, that's flipping the figure over a line of symmetry. And for our purposes, we're going to flip either over the x-axis, the y-axis, or the line y equals x. When we do a reflection over the x-axis, we multiply by this matrix. So we multiply our matrix of coordinates by this matrix. Over the y-axis, by this matrix. And over y equals x, by this matrix. Okay, rotations are similar, but we're going to rotate 90 degrees by multiplying by this, by 180 degrees by multiplying by this, or by 270 degrees by multiplying by this. So our first reflection is the triangle with these 3 sets of coordinates. So here it is put into a matrix. And we are reflecting over y equals x, or over the y-axis. So the y-axis, that's what we're going to multiply by. Negative 1, 0, 0, 1. Okay? So we've got negative 1 times 2 over and down is 0 times 3. Okay, so that gives us negative 2. Okay, then the first row by the second column, negative 1 times 4 and 0 times negative 2. Okay, first row by third column, negative 1 times negative 4 and 0 times 0. And then we go on to the second row by the first column, 0 times 2, 1 times 3. 0 times 4 plus 1 times negative 2. And 0 times negative 4 and 1 times 0. So those are our new coordinates. Negative 2, 3. Negative 4, negative 2. And 4, 0. So there it is reflected over the y-axis. So the y-axis is our line of symmetry. Okay, so now we're going to reflect over the x-axis. And if we go back and take a look at our different matrices, reflection over the x-axis is multiplying by 1, 0, 0, negative 1. Okay, first row by the first column. I get negative 2 plus 0. 6 plus 0. 0 plus 0. and negative 6 plus 0. Okay, so I've multiplied the first row by each column. Now the second row by each column. 0 plus 7. 0 plus 2. 0 minus 3. 0 plus 4. So those are my new coordinates. 0, 7, 6, 2, 0, negative 3. I have a problem with my first coordinate there. I should have had negative 2 plus 0. So that should have been negative 2, 7. Okay, and then I've got negative 6, 4. So there it is reflected over the x-axis. So that x-axis is our line of symmetry. Okay, a rotation. So we're going to rotate about some point, and that point for each of these is going to be about the origin. So the origin will be the center of our rotation. We're using multiplication again. So if we go back to our table, the rotation matrix for a 90-degree rotation is 0, negative 1, 1, 0. So we're going to rotate this matrix 90 degrees by multiplying by 0, negative 1, 1, 0. So first row by the first column is 0, minus 3. First row by the second column is 0, plus 2. And first row by the third column is 0, plus 0. Then the second row by the first column, 2 plus 0. For second row, second column, 4 plus 0. And second row, third column, negative 4 plus 0. So those are our new coordinates. So we've got negative 3. I'm going to erase that origin so it doesn't distract us here. So we've got negative 3, 2, 2, 4, and 0, negative 4. And there it is, rotated 90 degrees about the origin. And in our last problem, we're going to rotate 180 degrees. So we'll go back to our chart here. Rotation of 180 degrees, negative 1, 0, 0, negative 1. So we're going to rotate this 180 degrees. So that matrix again was negative 1, 0, 0, negative 1. Negative 2, negative 7, 6, negative 2, 0, 3, and negative 6, negative 4. Okay, so first row by the first column, we've got 2 plus 0. And the second column, negative 6 plus 0. 0 plus 0. And 6 plus 0. Then the second row by each column, 0 plus 8 plus 7, 0 plus 2, 0 minus 3, and 0 plus 4. So that's 2, 7, negative 6, 2, 0, negative 3, and 6, 4. And there it is, rotated 180 degrees.
All right, let's go back and practice a couple skills. We'll start with a 3x3 system of equations. To me, the easiest way to solve this system of equations is by eliminating the z's. So I've got a positive z and a negative z, so I can combine those two equations right there, the top and bottom. So I will get 8x minus y, and then the z's cancel and equals negative 18. Okay, then I could multiply this equation by 2 to eliminate the z's here. So I've got 2x minus 12y minus 2z equals negative 36. And I can combine those two equations to get x minus 9y, and then the z's cancel, and then 16 minus 36, that'll be negative 20. Okay, so now I can eliminate either the x's or the y's. Let's multiply this one here by negative 8. So I get negative 8x plus 72y equals, and then 20 times 8 is 160. Negative times negative is positive. And now I can combine these two equations. The x's will cancel. I'll get 71y equals, and then negative 18 plus 160, that's going to be 142. And I can divide both sides by 71 and get y equals 2. Okay, so there is my value of y. I could plug that in right here. So I've got 8 times 2 minus y. I'm sorry, I plugged that in the wrong spot. Cancel that. I've got 8x minus 2 equals negative 18. And I'll add that over to the other side and get 8x equals negative 16. And divide by 8 and get x is negative 2. Okay, so I've got a value of y, I've got a value of x. Okay, now for a value of z, it looks like maybe the bottom equation here would be the easiest. So I've got negative 2 minus 6 times 2 minus z equals negative 18. Okay, I'm going to switch sides with these, so I'll get negative 2 minus 12 plus 18 equals z. Okay, so negative 2 minus 12 plus 18 is 4. So I get z is 4. Okay, so the intersection of these three lines happens at negative 2, 2, 4. Okay, so now we're going to do some matrices. 5 times matrix B, so that's scalar multiplication. 5 times 8, negative 4, 2, 3, 1, negative 5. Okay, and when you're doing scalar multiplication, you just multiply everything by a scale factor of 5. So that would give us 40, negative 20, 10, 15, 5, negative 25. Okay, then we've got matrix A times matrix B. So matrix A, that's a 3 by 3. Matrix B is a 2 by 3, and those inner dimensions do not match. This is not possible. And then matrix B times matrix A. So I have a 2 by 3 and a 3 by 3, and the inner dimensions do match, so this is possible. So I've got 8, negative 4, 2, 3, 1, negative 5, times 4, negative 2, 3, 5, 0, negative 1, 9, 0, 1. Okay, and these outer dimensions tell me that my product will be a 2 by 3 matrix. 2 rows, 3 columns. Okay, so to multiply these, I'll do 8 times 4 plus negative 4 times 5 plus 2 times 9. Okay, so 8 times 4 plus negative 4 times 5 plus 2 times 9. Okay, so we go over with the left hand, down with the right hand. Okay, and that equals 30. So my first element is 30. Okay, then I do the first row by the second column. So I've got 8 times negative 2, which is negative 16, plus negative 4 times 0, plus 2 times 0. Those are both zeros. So it's negative 16. And then the first row by the last column. So I've got 8 times 3 plus negative 4 times negative 1 plus 2 times 1. And that is 30. Okay, then I go down to the second row and back to the first column. So I have 3 times 4 plus 1 times 5 plus negative 5 times 9, and that is negative 28. Then the first row, or the second row by the second column, 3 times negative 2 is negative 6, plus 0, negative 6. And then I've got 3 times 3, so I'm on the second row, third column, 3 times 3, negative 1 times 1, negative 5 times 1. So it's 3 times 3 plus 1 times negative 1 plus negative 5 times 1, and that is 3.